parameter like the mean, but it could also be standard deviation or the median or any of the other measures. So you estimate that from the sample, and now you build a confidence interval around the estimate that you obtain from the sample. Okay, so the estimate, the interval that you're going to build is going to be in the form of x bar minus EBM and x bar plus EBM. That's what you need. That's all you need. X bar minus EBM and x bar plus EBM. I'm assuming you can see my screen, and then you can see where I wrote the x bar minus EBM and x bar plus EBM. Right above that, then you see EBM equals Z star times sigma over square root of n. Okay? And then so if we replace EBM by that Z star times sigma over square root of n, then then the formula becomes x bar minus Z star times sigma over square root of n, and x bar plus Z star times sigma over square root of n. Okay? Um, so so you use this formula to compute or calculate the confidence interval. The all of those measures will be given in the problem, and the only thing you need to look for is your Z star, and your Z star is going to be based on the confidence level. And the confidence level can be something like 90%, 95, or it could be 95%, or it could be 98%, it could be 99%, but it could also be any confidence level outside those four, like 80%, 85%, 87%, 75%. It could be any of those. And I'm sure we went over how to obtain the Z star based on the confidence level yesterday. You always draw this graph, and then whatever the confidence level, you put it in the middle. That's your 1 minus alpha. And your alpha is whatever is left out of 1. So if you have a 99% confidence interval or confidence level, then you put the 0.99 in the middle of the graph, and you're left with 1%, which is 0.01. You divide that into 2, that gives you 0.005 for each of the tail. And then with that setup, now you go into the table, you obtain your Z star. Okay? If it's 90% confidence level, then you put that 0.90 in the middle, and then you're left with 10%, which is 0.10, and then you divide 0.10 by 2, and that gives you 0.05 and 0.05 for each of the tail. Based on that setup, then you will obtain your Z star from the table. We went over all of that yesterday, and we came up with these numbers that if you're doing the 90% confidence level, your Z star will be plus or minus 1.615. If you're doing 95% confidence level, your Z star will be plus or minus 1.96. If you're doing 90, excuse me, if you're doing 98% confidence level, your Z star will be plus or minus 2.33. And with 99% confidence level, your Z star will be plus or minus 2.575. We went over that yesterday. We obtained those numbers from the table, and I did explain that if you have any other confidence level different from these four, then you will analyze them the same way we did this one, which is whatever the confidence level, you put it in decimal form, and you draw the graph. The middle of it will be your confidence level in decimal, and then whatever is left over will be divided between the two tails. And based on that, then you go into the table, and then you obtain your Z star. Okay? Any question about that so far? Um, about obtaining your Z star. Okay. And then once you obtain your Z star, then you can put that in the formula and then you can use that to calculate the confidence level. So we went over this question yesterday where X bar is 68, sigma is 3, N equals 36, CL equals 90%. Okay, and then we know X bar will be normal, either based on the fact that the population distribution is normal or based on central limit theorem if we do not know the distribution of the population. Okay, so with that, and then so we calculated, so sigma is 3, N is 36, X bar is 68, and confidence level is 90%, and that gives you 1.645. You plug in all those numbers, and then we end up with this setup with all of the numbers in there, and then your margin of error, which is your Z star, which is your EBM, Z star times 3 over, no, 1.615 times 3 over square root of 36, excuse me, times square root of 36, and that end up to be 0.823. And then we did 68 minus 0.823 and 68 plus 0.823. And 68 minus 0.823 is 67.177, not 877. I think I explained that yesterday. Um, and so that was how we got that confidence interval. And what does that mean? That means that because we were doing 90% confidence interval, that means 90%, that means 90% of the time, 90% of the time, or 90 out of 100 times, the actual, I think, what was this again? Um, the test score, right? 90% of the time, the test, uh, the average for the test score, 90% of the time is going to be between 67.877, no, 67.177 and 68.823. That is the interpretation of that. And then we change the confidence level from 90% to 95%, and from 9% to 95%. And what that means is we're going to get a different Z star. And that different Z star is 1.96. That corresponds to 95% confidence level. So we change the 1.645, we change it to 1.96, and then we end up with 67.02 and 68.98. Okay, that was how we did that. And then I also posed some conceptual question or theoretical question is what is the relationship between the confidence level, relationship between the confidence level and confidence interval, relationship between confidence level and confidence interval. It may meaning that when confidence level increases, what will be the effect of that on confidence interval? As I explained yesterday, confidence level and confidence interval, they move in the same direction, in the positive direction. They have a direct relationship, meaning that as one increases, the other one will also increase. So if confidence level increases, then the confidence interval increases, or the confidence interval becomes wider when the confidence level increases. And if the confidence level decreases, then the confidence interval becomes narrower. Okay, the confidence interval becomes narrower. Um, so that is the relationship between confidence level and confidence interval. It's a direct relationship. They go in the same direction. they go parallel, side by side. Okay. Now the other relationship we look at is the sample size and the confidence interval. So we said sample size and confidence interval, they move in opposite direction. Sample size and confidence interval, they move in opposite direction. If you increase the sample size n, the confidence interval goes the other way, meaning the confidence interval um, decreases when you increase the when you increase the sample size. When you increase the sample size, the confidence interval decreases, meaning the confidence interval becomes narrower. And that means they have a negative relationship, or they go in opposite direction. Okay? So that was where we stopped. That was where we stopped yesterday. Okay? Now, there's something else that we also. Oh, okay. So, based on that, any question on that so far from anybody? Any question? Okay. If we don't have any question now, there's one more thing that we need to know with regards to confidence interval. Sometimes you'll be required to calculate the sample size that will give you, or to accomplish a particular or a specified margin of error, right? A specified margin of error. Okay, so you want to calculate the sample size. So now you're not obtaining the confidence interval anymore, but they're asking you for sample size. So look at the question that you're looking at on the screen now. Can somebody read that question for us for the class?
Professor, I'm not seeing a question on the screen.
Oh, can you see what do you see on the screen?
Right now, I see the 90%, 95 confidence level, 98%, 99. I don't see anything else. I'm just seeing the notes from yesterday.
Are you serious?
Yeah.
Professor, I can see the question.
You can see it?
Really?
Yeah.
Can you see it or you cannot?
I can see it, but
Well, this is China speaking, and I can't. Yeah.
Can you see something that says
So maybe I gotta
this?
reload my page.
Okay. Other than China, does everybody see what says something that says sample size calculation and its type? Can you see that?
I see it.
Okay, good. Can somebody read that question?
The population standard deviation for the age of Foothill College students is 15 years. If we want to be 95% confident that the sample mean is within 2 years of the true population mean age of Foothill College students, how many randomly selected Foothill College students must be surveyed?
Okay, so Johnny, tell me, what is the call of the question here? What part of this is the question that we're supposed to answer? That we're supposed to do?
Find the confidence interval of
Okay.
of a random.
Look again. Look again. What part represents a question to be answered?
How many randomly selected Foothill College students must be? Oh no, that's not it.
That's it.
That's it.
Johnny, that's it. That's the one that's asking you the question specifically. You were given prior to that, you were given a bunch of information.
Yeah.
And then the last part of it says, how many randomly selected Foothill College students must be surveyed, even with a question mark, right?
Mm-hmm.
Yeah. Okay, so don't go by what it looks like you're going by what you learn. Yeah, but what is the specific question? It's right on it. It says how many randomly selected food collections must be surveyed. What is that asking for? What is that asking for?
Um, it's asking for the
Anyone? What is that asking for? In English.
N.
In English. What is that asking for?
The sample size.
The sample size, right? The sample size is asking for the sample size, which is n. So it's asking you to calculate the sample size, and that is n. Okay. Now, before I show you what I have below that, so now look at this, and you tell me. I mean, anyone, tell me what we are given. So what are we given?
We're given the years and the 95th confidence.
Wait,
That-
let's take one thing at a time. One thing at a time. So what are we
Professor?
given? Mhm.
We're given years.
We are given years. Now, it's not just years. It's something measured in years, but it's not just years. What is it?
We're given standard deviation.
For
The population.
the population standard deviation. And what is the notation for that?
Sigma.
Sigma, right? You can write that down. We are given population standard deviation sigma. And what is that one? What is the value for sigma?
15.
15. Good. Next, what else are we given?
Confidence level. 95%.
Confidence level, what is it?
95%.
95%. What else are we given?
Sample mean 2.
Nope.
Oh,
What else are we given? Anyone?
X bar.
No. X bar is the same as sample mean,
Professor?
right? Yes.
This is China. I'm sorry, but I still can't see what you guys are seeing, so I'm just gonna leave and try to log back in, okay?
Okay, yeah, you should do that.
Okay.
Okay. So again, what else are we given? I know we've identified sigma. We have identified the confidence level. What else? I'm still waiting. Nobody knows? I'm going to go back to you, Lillian. You're kind of around it, but it's not what you think it is. So let's do this. Can you read that part, that statement aloud, and see if it will come to you what we are given? It's when that start with if.
Sure. If we want to be 95% confident that the sample mean is within 2 years of the true population mean age
Stop
of
right there. Stop right there. Okay. Does it jump out to you what they gave us? No. It says if we want to be 95% confident that the sample mean is within 2 years of the true population mean. The sample mean is within 2 years of the true population mean. Isn't that the margin of error?
Yes. Got it. Okay.
That is the margin of error that was given, right? So it is not the X bar. They didn't tell us that is the sample mean. They said if we want to be 95% confident that the sample mean, whatever it is within 2 years of the true population mean, meaning that the margin of error between the sample mean and the population mean is 2. Remember my first example yesterday when we did 45 minutes plus or minus 10? That's exactly what they're telling you here, that you don't want the margin of error, the difference between X bar and mu, you don't want the difference to be more than 2. Therefore, they give us the margin of error. Okay? So the margin of error is 2, meaning your EBM is 2. Now you need to calculate N, which is the sample size. Now to do that, you come right here. Do you see this? The formula for EBM? EBM equals Z star times sigma over square root of N. Do we see that? So we know sigma, which is 15, right? We know EBM now, which is 2. We know it's 95% confidence level, right? Then we can get the Z star. If you get a Z star for 95%, that is 1.96, right? That would be 1.96. Then, then you have the square root of N over here. And the only thing that we do not know in this formula is N. We know everything. They give us EBM, it's 2. We can get the Z star from the table, 1.96. We are given sigma, 15. The only thing we don't know is N, and that is exactly what the question wants us to calculate. All you have to do now is plug in all of those numbers in this formula and then solve for N. Okay, so let's go. So let me show you what I did over here. So sigma is 15, confidence level 95%, EBM equals 2, right? Then as a formula again, EBM equals Z star times sigma over square root of N, right? Then look, so you got 2 equals 1.96 over, you know what? Let me do this. Could you write this now that 2 equals 1.96 times 15 over square root of N and try to solve for N? Let me know what you got. Each one of you. So now that we know the formula, so when you calculate the sample size, this is the formula you're going to use. EBM equals G star times sigma over square root of N. Okay? So solve for N and let me know what you got.
I got 3.834.
3.834. Okay. Anybody else?
Professor, what was the question? You want us to find Z?
No, they wanted to find to solve for n.
Oh, okay.
Yeah.
I
We
got
know,
the same answer as Lillian.
we know the EBM is 2. We know sigma is 15. And Z star, because we have 95%, Z star I believe is 1.96. Now you just need to solve for n.
I got the same answer as Lillian.
What did you get?
3.834.
3.834. Okay. Anybody else? Something is telling me that that could not be the answer, but I may be wrong. Okay, we got from 2 people, they got the same thing, right? That was Lillian and was it China? The second person?
No, I believe it was Janae.
Oh, it was Janet. Okay.
No,
Lillian and Janet. Okay.
Or Tony.
Let me hear from
I'm
the other
sorry.
people.
I didn't say anything yet.
Oh, okay. So it was probably Tony, I think, that said the second answer, right?
yeah, it was me.
Okay, yeah.
Was it Tony or Janet?
No, it was Lillian and Tony that
I
gave
got
the first
Lillian
two
and Tony.
answers.
Okay. Okay, so we got from Lillian and Tony. And let's see if we can get from other people.
Is the answer 216.09?
I do not know, but we will get to that. But something in me tells me it could not be 3 point something. That it has to be a number bigger than that. So who gave the 216? Who gave the 216 now?
It was me.
And me is who?
No, Janae.
Janet. Okay. You may be right, but I don't know for a fact. But we're gonna get to it. So 2 people got 3 point something, and then somebody got. Now, Janet, did you get exactly 216 or 216 something?
I got 216.09.
I got 216.09.
216. Oh, Marian also got 216.09.
Yes.
Okay.
Oh,
Anybody
I'm
else?
sorry. Yeah, I messed up.
I got 0.36 for N.
Oh, no way. No way, no how. No way, no how.
Okay.
Okay. Some of you still trying it before I reveal the answer to you.
Okay, it's 216.09. I'm sorry. Yeah, I accidentally took the square root of 14.7 instead of squaring it. So
I made the same mistake.
Okay. I'm glad we can figure out what the mistake is. Okay. So I got 216.09 also, but look at what I did with my 216.09. What did I do?
You rounded it. Why though?
Good. What are we looking for? Tell me in the question, what are we looking for?
The population of people.
Not the population, but the sample size, right?
Sorry, the sample size of people.
The sample size of what?
The sample size of the age of the college students.
With the sample size, what is the sample size of what? Of who?
Of how many students must be surveyed?
College students? Is the sample size of college students, meaning how many college students do we have to survey? right? How many college students do we have to survey, right? So how do you survey 216.09 students?
Professor, I'm just confused as to why you had to round it to 217 and not just keep it at 216.
Well, I'm getting to that. And that's why I'm asking you, how do you survey 216.09 students?
Because
Well,
you can't have half of a
How do you
person.
do that?
Yeah, you can't have like a fraction of a person, so you have to round it up to a whole number.
Exactly. Because you're dealing with something that is discrete, there is no partial. Once you need any little tiny bit more, then you go for a whole. This is not the regular rounding that we do. This is not the conventional rounding where if it's 5 or more, you round to 1, less than 5, you throw it away. Yeah, that is in abstract calculations. However, when you're dealing with something that you got a sample size, something that we count, people, number of cars, number of buildings, right? Especially when you're dealing with people. So you cannot have, it doesn't matter how small it is. If you did 216 and you need a little more, right? Then you're going to get one more person. Isn't that what you're going to do? If you have 216, you need a little more, you get one whole person. So therefore, the 216.09 will not follow the conventional rounding, right? It will not follow the conventional rounding. So that is why it is 217 instead of 216.09 or 216. It will be 217. Does it make sense now? China, someone that was asking me, why did I do
yeah, that makes
217?
sense. That makes sense.
Yeah. Yeah. I mean, it's like if you're trying to lift a heavy load, right? You're trying to lift a heavy load, and let's say you need 5 people and 0.09. That means 5 people may not be enough to lift that heavy load. Even though you need like a little bit tiny of a person, maybe you need a finger to add more to that, but you're not gonna just take somebody's finger and cut it and bring it over, right? You bring the whole person over, even though you only need his finger for the support. You bring the entire one person, you bring him over, right? So you add one more person to it, not a little bit of a person. And that's why for this particular type of calculation, you have to round up regardless of your decimal point. Regardless of your decimal value, you round up. Okay? Regardless of decimal value, you round up. It's 216.09. And that becomes 217. But for this kind of test, and for this kind of question, I'm going to be looking for that rounding part of it. If you didn't round it the right way, you're not going to get the full credit. I'm going to deduct some points. Or if you just leave it with the decimal, I'm also going to deduct some points. Okay? This is why if you're doing the sample size calculation, it doesn't matter how small. It doesn't matter how small your decimal part of it is, you're still going to round up to a whole. Is that clear now? Is it clear?
Yes, it's clear, Professor. But I see all your work, but I just don't know what steps were taken first in order to get the answer, get n by itself.
Okay. So do me for right 2 equals 1
I wrote out the.
times 15 over square root of n, right? Okay. We're trying to solve for n. N is in the denominator, isn't it?
Yes.
So we need to find a way to bring n into the numerator. So multiply both sides by square root of n. When you multiply both sides by square root of n, then the square root of n on the right side in the denominator is they're going to cancel out. And you're going to have square root of n times 2 on the left hand side equals 1.96 times 15. And now you divide both sides by 2. If you divide both sides by 2, it should give you something like 14 point something.
Let me see. 1.94 times 15.
1.96. Where did you get 1.94 from?
Oh, I said 0.94, but I put it in the calculator as 0.96. Sorry.
Okay.
Divided by 2, you said, right?
Yeah.
Okay. All right. And then.
And then you have the square root of n, right? So you square both sides. Not taking the square root of both sides, you square both sides. When you square both sides, the square root on the n disappears. Then that leaves you with n by itself.
That makes sense. Okay, Professor, yes.
Okay?
Uh-huh.
That's how we got it. Now, to make life easier for you, look at what I have in the box.
Oh, wow. Yes.
If you just go back 2 steps above that, you see where it says 1.96 times 15 divided by 2, and then you have squared, right?
Mm-hmm.
Yeah, 1.96 is your Z star, 15 is your sigma, 2 is the EBM, right? And then you square that, and that gives you a formula, a direct formula.
Yes, that's the direct
to calculate
formula,
n. So n will be your Z star times sigma divided by EBM, everything squared. And that gives you your n.
Mm-hmm.
Okay?
Yes.
Yeah, look at it again right below that, below the box. Look at it again. If your Z star 1.96, sigma is 15, EBM is 2, everything squared. Okay?
Yep.
Okay. Any question?
Do you have another example maybe that we could do again?
Not with me, but if you go back to the assignment that I gave you, and then there will be at least 1 or 2 questions asking you to calculate the sample size.
Okay.
Okay. You know, one thing I'm also thinking of doing is I may send you a question, maybe 1 or 2 questions a day, and ask you to do it and send it back to me for credit.
Okay, yeah. That'll be nice.
How about that?
That sounds really good.
Yeah.
It
So
gives
that would be
people a
so
chance
first
to get
of all,
some
there should
extra
be 1 or 2
points.
questions in the assigned homework, and then I'm gonna try and find a question that I'm gonna send to everybody. Then you do it for credit, maybe like for 10 points, for 10-point credit, something like that. Okay, and then you send it back to me. I will tell you when I'm supposed to get it. Okay. And one thing about that is that when you see a question like this on your final exam, then if you have done this one that I'm going to send to you, then that will give you some confidence as to, okay, I think I can do it. Okay? Is that okay?
Sounds good. Yes, sir.
Okay, good. Okay, good. Okay. So, I mean, I wish we can do more for the semester or for the session, but we can't. You know, we don't have time for me to introduce a new topic. So we're going to stop here. This is as far as we can go. This is a very short session, 6 weeks. We try to pack in as much as we can and move at a pace that we can. So this is as far as we can go. So at this point, I'm going to switch to the test, the test that I just took, that I graded, and let's go over that test. That I think we can benefit more from that as opposed to me starting a new topic. Okay? Can you see my screen? Oh no.
Yes, it's still on
Okay.
the example we did.
Oh, okay. Not the example. Can you see the test now?
Yes.
Okay. So let's start with the first question. It says the time for a female student to commute to SCSU is uniformly distributed with minimum of 20 minutes and maximum of 80 minutes, right? A randomly selected female student is selected. Well, let's use twice. Okay. So what kind of question is this?
Uniform distribution.
Uniform. How do we know it's uniform?
Because it says it in the question.
Because it says uniform in the
Fully
question.
distributed, yep.
So then you see what I did? X without wiggle sign, then U 20 comma 80. Right? Right? And then so with that I can obtain my f of x, which is 1 over 80 minus 20, and that gives me 1 over 60. Right?
Yes.
So my f of x is 1 over 60, and then you find the probability that commuting time is between 35 and 50. Right? That is just, you see, I sketch the graph, the entire distribution from 20 to 80, and I put in 35 and 50 somewhere inside it, and probability of x between 35 and 50. Right? So it will be, so we find that area is 1 over 60 times 50 minus 35, which is the length of that shaded rectangle. And that turns out to be 15 over 60, which is 0.25. Right? And then probability of x greater than 65. Even if it's greater than 65, it's not going to go beyond 80. So it will be x between 65 and 80. Right? So let's sketch another graph for the B that you can see between 65 and 80. Right? So that means, again, you're going to do the height, which is 1 over 60 times the difference between 80 and 65, which it turns out to be 15 also. So it's 15 over 60 is 0.25. C, this is the conditional probability part of it. What is the probability that it's less than 35 minutes given it is less than 50? Then you set it up. Then you see that x less than 35 intersection x less than 50, which is the overlap, right? Which is the overlap, and you go on you sketch the graph. If you do it the way I showed you, then you will see the overlap between the two, and the overlap turns out to be from 20 to 35, and 1 over 60. So 20 to 35. So to find that area would be again the height, which is 1 over 60 times 35 minus 20. Then divided by probability of x less than 50, meaning x goes from 50 to 20. Okay? And that will also be 1 over 60, 50 minus 20. 1 over 60 at the top and 1 over 60 at the bottom cancel out. That leaves you with 15 over 30, and 1/2 is 0.5. Okay? And then the 85th percentile, that means
Professor,
probability
before you move on, I'm sorry, before you move on, where did you get that 20 from? Still on C, where did you get that 20 from?
Which 20? 20 where? Where did I
in your
tell me
calculations?
But tell me specifically where you'll see the 20 that you're talking about.
Okay, so if you look down, so you see how you wrote out the problem and then you equaled it. So it's 3 equal signs. The third line.
Okay.
The
Okay.
1 over 60, and then times 35 minus 20. Where did you get that
Okay.
20 from?
Okay. Stop right there. Okay. Go back one step above that.
Okay.
You can see that at the top it says probability of x less than 35. Do
Okay.
you see that?
Yes.
Okay. The probability of
Oh,
x is
okay.
less
So
than
you did
35.
the. Okay, that makes sense. All right.
Let's go. I mean, go to the graph. If x is less than 35, go
We
to
got
the
to use the
graph.
formula of the area to the left.
Yeah, because x
Okay,
is
that
less
makes
than
sense.
35.
Okay, that makes sense.
Right?
Mhm.
Yeah. Yeah. X is less than 35.
That makes sense.
That is between 35 and 20. Because 20 is the minimum. So if it's less than 35, it cannot go below 20.
And then less
Right?
than 50. Yes, that makes sense. Okay.
Okay, good. And the D part, I think a few number of people kind of made some mistake on this one. You say you want to find 80th percentile. Look at my graph, right? You go from 20, K, and 80, right? You start from 20, then K, and then 80. So we want to find probability of X less than or equal to K. Probability of X less than or equal to K, right? That has to be 0.85. So look at that shaded part. We want to find the area. It will be the height times the length. The height is 1 over 60. What is the length? The length is K minus 20. Some of you had K minus 0. Some of you had K minus 1. Those were from the previous problem that we did. Right? That is not
Yeah.
this problem. The minimum in this problem is 20, not 0, not 1. So if you do K minus 0, that will not be right. If you do K minus 1, that will not be right.
Yeah, because you got to follow the formula, which is your A. So the A always changes in certain
Right.
problems.
Yeah, the A here is 20.
Yes. Mm-hmm.
In previous problem, in one, A was 0. In another one, A was 1. But this one, A is 20. Right? Okay, so there are some people that kind of made that mistake. Okay, so if you now put them,
I have a question.
okay.
What if we mistook the 0.85 for 0.80?
Could you repeat that question, Jade?
I said, what if we accidentally mistook the 0.85 to 0.80?
Then you're gonna get the wrong answer. Because they're not asking you for 80 percentile, they're asking you for 85th percentile. And
Yeah.
you were doing the problem based on 80th percentile. Right?
Yeah.
So you're gonna end up with the wrong answer.
Professor,
Now,
I have a question. I'm sorry.
okay, before you ask me that question, let me finish this part.
Yep.
So if I then look at that, if all of your steps are right, other than you use 80 instead of 85, then I'm not going to give you 0. I will give you some points for it, but I'm not going to give you the full credit for it because you just made up your own question.
Great, thank you, Professor.
You're welcome. Then somebody have another question.
Yeah, it was China. So I noticed on your solution worksheet that you included graphs for everything, and I know it wasn't required, but for those that did include it, I'm assuming you gave out extra points.
No, I did not take any points out. The graph
okay.
is a tool
It's
to
just
help
there
you.
to help us. Okay, perfect.
Right.
All right. Okay, just
Right,
making
but
sure because I was like,
if
I
you
did
not
not
put the
include
graph,
any. So.
you may made a mistake. And
Okay.
also for teaching purposes, I want you to be able to see exactly what I'm doing.
No, yeah.
Okay.
Yes, that makes sense because it also helps. That way you know if it's left of X or right of X. That way you know what formula to
Yep.
use.
Yep. Thank you.
Yep.
And then E, find the mean and standard deviation of the student commuting time. Right. That should be a straightforward question. Mu is A plus B over 2. Sigma is square root of B minus A squared over 12. And for mu, you will get 50. For sigma, you get 17.32. Okay? Any question in any part of this number one? You see, on the final exam, most likely you will see another uniform distribution question. That will be like the fourth or fifth time you're going to be saying it. So even if you struggle with it in the beginning, by now you should be good at it. You should be a pro by now. Okay? Okay. So can we go to the question number 2? Yes? No?
Yes.
Okay. Question number 2. Can somebody read that question for me? Number 2.
You want us to read it, you said?
Yeah.
Okay, the scores on the math SAT are normally distributed with mean 450 and standard deviation of 75. To get into Springfield Tech, a large university, a student needs only at least 500 on the math SAT. However, any student that scores below 500 but above 400 on the math SAT will automatically be placed on the waiting list.
And what is the first question?
Oh, can you just slide down a little bit, Professor? Find the, oh.
Yeah, right. You can read it.
Find the probability that a random student who takes the math SAT gets into Springfield. Is there more to it, or is that it?
No, that's it.
Oh, okay.
Yeah. Get into Springfield College, right? Find the probability that a random student who takes the math SAT gets into Springfield College. So, what do you have to have? What do you have to have to get into Springfield College? What do you need to have? Anyone? What do you need to have? You need to have 500 or
higher.
500 or more, right? So that means you need to find probability of x greater than or equal to 500. Right? See how I write x is normal 450, which is the mean, 75 is standard deviation. Right? And I want to find the probability that x is greater than 500, greater than or equal to 500, right? Okay? So see how I say that probability of x greater than or equal to 500 is the same as probability of z greater than or equal to 0.67. How do I know that? Because I use the conversion formula z equals x minus mu over sigma, right? So it'll be 500 minus 450 divided by 75. And that calculates to 0.67. Okay? And then what is the probability? So probability of x greater than or equal to 500 translates into probability of z greater than or equal to 0.67. Right? Which is the same as 1 minus probability of z less than 0.67.
Professor?
Yes.
It's China again, I'm sorry. So I noticed how you round it, whereas I just kept it as the decimal to the fifth place value. So you see how you did it as 0.67? Is it the same if I kept it as 0.6667? Because my answer is my.
Okay, hold it. Because when you go into, because now the next step is to go into the table, right?
Yes.
If you go into the table, you only need your z value to be in 2 decimal places.
Okay, see, that's where I messed up. Okay.
Right.
Because I noticed from our answers, yours is 0.2514 and then mine is 0.2525.
I don't even know how you get to 0.2525. Can you tell me, where did you get 0.2525 from?
Because like I told you, I kept it I didn't keep my answer in the 2 decimal places.
But to use the table, you have to keep your answer in 2 decimal places. To use the table, you have to keep your answer in 2 decimal places. You can't
that's where I messed up.
You can't use 4 decimal places in the table. Can you? No. you have to keep it in 2 decimal places to use the table.
That makes sense. Okay.
Right? Now, tell me something, China.
Yeah.
In the table, do you have that 0.2525 in the table?
No.
Because I was looking for it. I
I
couldn't
have to
find it.
look. Well, I got. Hold on. I got it from. Let me see, because now I gotta go back to the chart. Let me see.
Yeah, please.
Hold on.
Can you see the table now or no on the screen?
Oh, did you put it up? Okay. Thank you for putting it up for me because it was gonna take me a while to find it.
Can you see it? Can you see it though?
Yes, I could see it. So yes. So let's.
Okay. So you're looking for 0.67, right? It will be
Yes.
0.6 here and 0.07 over here. So where did you get 0.2525? Now, yeah. So I'm waiting to see where some of you get that 0.25 because there are good number of you that got 0.2525. And I'm wondering where that came from. I want someone to explain to me where the 0.2525 came from. Okay, let me do something right here. Because some of you lost me on some part of it. What am I looking at here? 0.7454. 1 minus 0.7454. That gives me 0.2543. So where did the 0.25 China? Where did you get 0.2525 from?
I think I just calculated it wrong. I think what threw me off is keeping it in the four. I don't even know. Yeah.
Yeah, but if you stay with me for a moment, even if we go by what you have and what you do, okay? Where did the 0.2525 came from? Antonio. Antonio, are you there? Antonio. Is Antonio there or he left? Let's see.
Oh yeah, a lot of people left. I don't know.
Oh, a lot of people left?
I mean, don't we have like 14 people in our class?
No, I think we left with about 10.
Oh, okay. So then we're only
We
missing.
started with about 14. And we have about 10. But I'm talking about those people that took the test. I'm calling on the name of those people that took the test. So has Antonio left? Um, just give me 1 second. Okay, so Antonio left. I see I have Tony here. I have Lillian. I have China. I have Ronnie. I have Janae. And I have Miriam. Okay, so so Antonio left. So is Yaslin back? Because she's supposed to come late. Okay, Yaslin not here. Okay, I've been talking to China. How about Tatiana? She left. Wow. How about Ronnie? Is Ronnie here?
Yeah,
He
I'm
left.
here.
No, Ronnie's here. Okay, Ronnie, tell me, you got 0.2525 also. Where did that come from?
I think I did the same thing as China and just left it at 0.666667. I think
Right.
mine just rounding.
If you're living at 0.6667, how do you end up with 0.2525? I want you to take me through that step. Where did you get? Forget about what I did. I'm going by what you did. With what you did, how did you end up with 0.2525? Do you know?
That's a good question. I'm looking at my notes right now, but
Yes.
I did a lot of the calculations in the calculator, so all my notes are kind of scrambled up here.
Yeah, but you still need to obtain, you still need to get to go to the table. And I'm looking at the table, I don't see how you end up with 0.2525 from the table, even with what you have.
I might
Let me,
be
yeah,
able
go
to
ahead.
help. So I got 0.2514, but I'm looking on like Google for other tables, and there are other tables that give like more like the exact values for like things beyond z-scores beyond 2 decimal places. And so if they had used another table, that would have been the exact answer.
What other table are you talking about? Do you have it?
Well, there are like calculators for z-scores, and I just Googled it and found one, and the answer is rounded is 0.2525 or
Okay,
2524 or something.
you just Google. I'm trying to understand where this. Okay, linear. So what did you Google? You Google number distribution table.
I just Googled like z-score, like percentage calculator. This is not what I did on the test, by the way. I'm just trying to figure out.
Yeah, I know. I'm trying to understand this too. I'm trying to understand the process, how the student came up with 0.2525.
I'm
So
gonna
take me through. If you understand it, Lillian, take me through it.
yeah. So I'm gonna send you the link in the chat. I don't know if you can see that, but
Okay. And then what does it say?
So obviously I did 0.667, but they probably found a table or something that did 0.66667.
Now, the table that you're talking about, does it have the z value to 4 decimal places?
No,
I'm not talking about the probability, which is the body of the table, but the z value. Do they have it to 4 decimal places?
No. Yeah, we should use the chart that you gave us. I'm just trying to explain maybe that other people use other charts. I'm not sure.
Yeah, I know. I'm just trying to follow you. I'm not going by what I did or what you did, but I'm trying to follow your explanation for how they got 0.2525. And I'm just wondering, where did that come from? Are you saying there is a other table which I believe we do have, right? But my first question with the other table is, do they give the z value to 4 decimal places or to 2 decimal places? That's my first question. Is the z value in the other table is to two decimal places or 4 decimal places?
I have no idea what other people did. I don't know.
But you said you just Google something and you're looking at it right in front of you, right?
It's just like
when you Google something,
calculator.
Do you have a table? Is it a table that you're looking at similar to the one that we have here, or you're looking at something else?
I'm personally not looking at a table, but yeah, actually, you know what? Never mind. Disregard everything I said.
No, I'm just trying to. Okay, Let me go. Marianne, you also got 0.2525. Can you tell me how you got 0.2525, Marianne?
Just try it, then Google it. It's more easier for the
You just
number.
Google it.
Yeah, it's a calculator.
So what do you Google? Tell me, what do you Google? When you go into Google, what do you put in? What do you Google?
Standard normal for 0.666.
Oh, okay. So you ask Google just that specific question, not a table, but that specific question of what is the probability that corresponds to z equals 0.6667. Is that what you're saying?
Yeah.
Oh, and it just gives you that 0.2525.
Yes.
Oh, okay. I'm trying to learn. I'm trying to learn because I was looking at that. I'm like, okay, how can this many people get this 0.2525 and I have no idea where they got it from? Okay. So you just ask Google what is the probability when you have the z value to be 0.6667. Is that what you did, Marianne?
Yes, I don't have time to go to schedule and turn it back.
I just want to understand how you guys came up with it.
Yeah.
Okay, I just want to know how you guys came up with it.
Yes.
Okay, so you just ask Google the question and it just gives you the answer. Okay, got you. Okay, let's move on. Oh, where's my? Okay.
So, Professor, I have a question on that. So, how are you going to handle that since most of everybody got the same answer?
Are you dumb?
We still get it wrong since it's not the answer you had?
No, you didn't get it wrong, but I put a question mark on it because I was going to ask you say some of you got exactly the exact same answer I got, which is 0.2514.
Oh,
and there are a few people that got 0.2525.
okay. So we'll probably get like partial credit.
It's not too far away from 0.2514 that I got. But I was just curious as to how that many people got 0.2525, and I can't find it in the table. But I did not take points off for that.
Okay, because I was gonna say, because B kind of relates to A. So if we use the answer we got in A, does that make sense? Like our answer is gonna be different for B too, since we use the since we got 0.2525. Does that make sense?
Okay. Kind of. So if you use 0.2525 in B, then how about the rest of B?
For B.
Mm-hmm. Yeah, is B.
Go down. Yeah.
Right?
Mm-hmm. Find the probability that a random student.
Find the probability that the random student takes the right side is placed on the waiting list. To be on the waiting list, what do you need to have to be on the waiting list?
Below 500, but above 400.
Okay. Below 500 and above 400, right?
Mm-hmm.
Okay. So, so, yeah. Okay. So then what do you need to do? Then taking it from there, then what do you need to do? What should be the next step?
So I set it up the same way where z equals x minus mu divided by sigma.
Yeah.
So I got 400 minus 450 divided by 75. And then from there I got the negative 0.66667. Once again, I didn't keep it in the two place values.
Right.
But then but that's the first step. And then the second step was to find the probability of x greater than 400. So then I did the probability of z greater than negative 0.66. I'm gonna just say 67, but you know that I did it in 4 place values. But I got 0.7475, and then I
Yeah, that's another one that threw me off.
okay.
0.7475. Okay.
Okay. Well, yeah.
Okay, do me a favor, all of you. Okay, do me a favor, all of you. I want you, because I'm not gonna go on Google to find out what the answer to Google is or what Google is presenting. I've explained to you how to do it. We have a table, how to do it. You please, for those of you who are in class now for your final exam, use the table.
Okay.
Okay? Because if your answer is different from mine, I may not give you the full credit.
Mm-hmm.
Yeah. There's a standard number distribution table, and that is what we're supposed to be using. And if you use that, you should get the right answer. If you go someplace else and your answer is different from mine, I'm not going to give you full credit for it. Especially if the answer is different from what is in the table. If it's different from the answer that we find in the table, then I'm not going to give you full credit. I know not everybody's here, but if you're not here, you are responsible for whatever went on in class. Because I'm not going to be going on Google researching what answer does Google have, right? I did not teach you to use Google, right? And I didn't use Google. There's a standard number distribution table for you to follow. If you get a different answer from mine and I look in the table, I can find the answer in the table. Yeah, that's something completely different. Can't find the answer in the table, I'm not going to be going on Google to find what is on Google. Okay? So for those of you in class, I hope you understand that you follow that. Okay? Does that make sense?
Yes, sir.
Yeah. So that is the table we follow, and
For
that's
future reference, yeah.
Yeah, that's what I used to teach you, and that's what you should follow. Okay? Because if not, I have to be going on Google and be searching what Google has, and it's not everything you get on Google is right or anyway.
No, yeah, that makes sense.
Okay.
No, yeah.
Okay. So, yeah, go ahead.
I was just gonna say, like, yes, it makes not a huge difference, but it does make a difference when you don't keep it to 2 place value. Because for B,
yeah, you see, in your case, when you get 0.6667, which is the same thing that I got, but you round it to 2 decimal,
that's
it
what I'm
becomes
saying.
0.67. It becomes 0.67. Okay.
That makes sense. And for B, the answer wasn't that much different, but like you said, if we don't have the same answer as you, we won't get full credit. But by doing it with the 4 place value, I got
if the answer is not obtainable from the table, if I can't look at the table and find what you got in the table, I'm not going to give you full credit.
That makes sense.
Okay?
Yes.
Okay. So now we go to C. For C, again, you use K here equals Z times sigma plus mu. And because we got 95.95 here, Z is 1.645, then times 75 plus 450, 573.38. Okay?
Yes, and then once again, Professor, in your case, you rounded, right?
So which one?
For you got 573.38, whereas I didn't round, so I got 573.375.
No, yeah, I mean, essentially we got the same thing.
Okay.
Yeah, essentially we got the same thing.
Okay.
Because if you're gonna round it to 2 decimal places, it will also be 0.38.
Okay. Yep.
Okay.
Yes.
Okay. So how about D? That is a Go ahead.
Can you just go step by step for D, because That was one question I was completely lost on.
Okay, D. Okay, D is a question to challenge you, to challenge all of you in the class. It's a combination of binomial and normal distribution combined into one single problem. But I gave you a hint, right? It said from a random sample of 10 students who took the math SAT, find the probability at least one gets into Springfield Tech. That is a binomial problem, right? If you have a sample of 10 students and the probability that at least 2 of them get in, is either you get in or you don't. So that's binomial, right? However, what is the probability of getting in? What is the probability of success? Probability of success was calculated in A, and it turns out to be either 0.2525 or 0.2514, which I rounded to 0.25. Are you with me, Janae?
Yes.
Okay. So it is a binomial problem, but how do you get the probability of success P? And that's why I said hint, use the answer in A above for probability of success. So that is to direct you, right? And then if you look at my calculation now, I wrote probability of one student gets in is probability of X greater than or equal to 500. And from A above, that was 0.25. And now you got a new variable. I use Y instead of X. Y now is binomial with N is 10 and P is 0.25. Okay? And probability, now when the probability of Y greater than or equal to 1, which is 1 minus probability of Y less than 1. Right? And then you find probability of Y equal to 0. That gives you Y equal to 0 is 10C0, 0.25 to 0.75 to 10. And that equals 0.056. And now that is probability of Y equal to 0. But what you want is 1 minus probability of Y equal to 0, which turns out to be 1 minus 0.056, which is 0.944. Isn't that a cute problem, Janae? Janae, are you here with me?
Yeah, I'm here. I was just like,
Yeah.
when I was reading through, I didn't know how to tackle the problem. So,
Okay, but yeah, but you see, I believe you did pretty well on the test. But maybe you struggle with that one. But it is a binomial problem. But
okay.
you need to obtain the probability of success. Okay, probability of success, and probability of success is obtained from the question A. And at point two, you get 0.2525 or 0.2514, then you can write it to 0.25, which is what I did.
Okay.
Yeah. You can, write the steps down and then go over it again yourself.
Okay.
Yeah.
And Professor, that's another thing. I know that we're going over it now, but do you think you could email this the solution to everybody?
Yeah, well, now really, but because I have it on the board, I have it on the screen. I expect as I'm going over it, then you're writing it down.
No, yeah,
So
I am, yeah, but as far
yeah,
as the people
write
that
it
are
down.
here,
Write it down so that I won't have to email it. And that's right. You see, I'm now writing so you can see. You can write it down. So I won't have to email it.
No, yeah, I understand for those that's in class right now, but I was only looking out for the people that's not here, you know?
That's their problem. You're supposed to be here.
I know, that's not our problem, I know, yeah.
Right. They're supposed to be here. You see, there are a good number of people who are here at the beginning of class and they just went away. The class is not over. You're supposed to be, remember in the beginning I said you're supposed to be in class from the beginning to the end. You don't sign on and then disappear. And then I have to be I have to be doing home delivery for you. No.
No, right. Yeah, you're right, sir.
Yeah.
Mm-hmm.
No, I'm not Domino Pizza.
Professor, I just have one more question on this problem.
Okay.
We found our P and our Q.
Right.
But could you go over why did we subtract 1?
Okay. Okay.
Maybe
Look
like
at.
like
Okay.
18.
Let's go back to the problem. It says from a random sample of 10 students who took the math SAT, find the probability that at least one gets into Springfield Tech.
Mhm.
Right? At least one gets into Springfield Tech. If you look at my second to the last line, okay, my second to the last line, you will see it says probability of y greater than or equal to 1, right? Y greater than or equal to 1, right?
Mhm.
Yeah. So y greater or equal to 1, that means 1, you do y equals 1, 2, 3, 4, all the way to 10. But you don't want to do that because it's going to take you forever. Then you go to the other side and then you do y less than 1, which is 0, and then you subtract from 1 because the total probability must add up to 1. Does that make sense now?
Okay, and then you put like y to equal to 0. Okay, and that is
Yeah,
0.
less than one means 0, right?
Yeah,
A number less than 1 is 0, right?
yeah. Okay, I see where that came from now.
Yeah. But write it down, write everything down, and go over it. If you have question, email me the question.
Okay.
Okay? Okay. We're done with number 2. How about number 3?
I found number 3 really easy
Okay, that's good.
because yeah,
It's a sampling distribution question, right?
yeah.
Right? It's a sampling
Sorry, yeah.
distribution question. And you are given the mean mu for the population and the standard deviation sigma for the population, right?
Yeah.
And then they give you n equal to 36. And the the first question is what is the mean and standard deviation of the sample mean x bar?
Mm-hmm.
So mu of x bar equal to mu, which is 32. Sigma of x bar equals sigma over square root of n, which is 10.2 over square root of 36. And that equals to 1.7, right? And then, so that is A. And B is distribution of the sample mean. What is distribution of the sample mean? Now, we don't know the distribution of the population. That means we have to use the CLT, right? And based on CLT, X bar will be approximately normally distributed, right? We are approximately normally distributed since n equals 36, which is greater than 30.
Professor, what I worded it like n is greater than 30 to resemble a normal distribution curve. Would that be like is that like the not
Again, based on whatever you wrote, I've read it and I've given you points on that.
okay.
Okay, because I
Okay,
graded it
yeah, because I
already.
was gonna ask how you were gonna grade
Yeah,
that question.
I graded it already, and I'm not sure if what you wrote is exactly what you just told me now. But I went by what you wrote down, and and um I graded it. I don't know if I took points off or not. But there are a good number of people that did not say where that came from, meaning that they did not indicate that that was coming from central limit theorem. In that case, you're not gonna get full credit. If you did not say that that is based on central limit theorem, you're not going to get full credit.
Okay. All right.
Even if you said everything that's right.
Yeah, because I was just about to ask, what is CLT? So that makes sense. All right.
Yeah. It's that based on CLT. I used that before. I used that in class many times. Central limit theorem, CLT. So
Okay.
X will be approximately normally distributed. How about C?
C, I got or the way I
Yeah.
lined it up was probability of X bar greater than 34.5 equals 1 minus probability of X bar less than 34.5. And then from there, I did 34.5 minus 32 divided by 1.7, and I got 1.47. So then from there, I did 1 minus the probability of Z less than 1.47, and then I got 0.9292, but I had to subtract that from 1, and that's how I got 0.0708.
Yeah, which is the same that I did. We got the right
Yes,
answer.
exactly. Literally the same thing as you. Yep.
Okay.
Oh wait, but I do notice something, Professor. Would I get points taken off because I noticed that I didn't put a less than or equal to. You know what I'm saying? I just put less than, but I still got the same like answer as you. You know what I'm saying?
Um,
For your second line after probability of Z is greater than 1.47, and then the next line after that, you see how you put 1 minus probability of Z is less than or equal to? I just put less than.
could you say that one more time?
All right. So you see how your second line, 1 minus probability of Z less than or equal to 1.47.
Right.
Yes. So you see how you wrote it out? I didn't put it as equal to. I just put less than. But I still got the
So
same
it's the
answer
same
as
thing.
you.
Either less than or less than or equal to, because it's continuous distribution. It's the same thing.
Okay. Just making sure. Yeah. Okay.
Yeah. Yeah. That's fine. Yeah. That's fine. Anything else?
No.
Okay. Um. Then we go to the next one. All right. This is C or D. um. So now, so D. Do you see what I wrote for D? Do you see what I wrote for D? Between the one to find between 31 and 34.5, right?
Yeah.
So that means you convert both. Right? So you convert both. So you got negative 0.59 for one, positive 1.47 for the other one. Right? So it will be Z less than 1.47 minus Z less than negative 0.59. Right? So I got 0.9292 for one and 0.2776 for the other one. Which is 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. 0 0.6516. Any question about that? What about E? So that is the one that you have to find 90th percentile, right? And 90th percentile, then using the formula, Z star times sigma x bar plus mu of x bar, and then because 90th percentile, Z star will be 1.28. And the answer to that should be 34.18.
Oh, I forgot to do the second part to that question. So, Professor, can you just slide back up? Yeah, thank you. Let me, I'm going to take a picture of that.
Yeah, you can. That's another thing. You can take a picture.
Oh, yeah, I don't want to hold up the class by me trying to write down everything. So, yeah, you can move on. I'll write it down later.
Yeah, but you can. Have you taken the picture?
Oh, yeah. Mm-hmm.
Okay. Then number 4. Now, so this is now a true binomial question. So you got 10% of students are left-handed, then a random sample of 15 students. So find the probability exactly 5 of the students are left-handed, right? So that means x is binomial, 15 comma 0.10, and then probability of x equal to k equals nck, p to the k, q to n minus k.
For right? That one, I rounded, sir.
What did you round?
So my answer was 0.0105.
Yeah, that's fine. That's fine.
Okay. Mm-hmm.
That's fine. That's fine. How about the second one?
For B, I got 0.
Yeah. Well, I don't know how you got the 0, but yeah, I mean this would be almost 0, but I'm still looking for the number for the answer.
Oh, I could so for that specific question, I did write out some of my work, so I could tell you how I got 0 at least.
Okay.
So I wrote it out as probability. Oh.
Yeah, go ahead.
Okay.
Yeah, go ahead.
I wrote it out as probability of x is greater than 12 equals probability of x less than or equal to 12. So for the first part of it, it was 1. And then the other part was 1.0000. So I just 1 minus 1.
Wait. Could you say that one more time? You said you wrote probability of x greater than 12.
12, yes.
Equals to be equal to
probability of x less than or equal to 12.
No.
That's so right. Then that's where so
probability of x greater than 12 cannot be equal to probability of x less than or equal to 12. No, that's not true.
Okay, so then it's probably just I feel like my first step I got it wrong, so by following through with the how can I say basically what I'm saying is I was wrong from the jump, but I kind of still went with what I got, so that's why I was wrong. But
okay, yeah, it's probability of x greater than 12 is the same as probability of 1, is the same as 1 minus probability of x less than or equal to 12. That part will be true. But why do you need to do that when you can just calculate x equal to 13, x equal to 14, and x equal to 15 and add them up? Okay? The x equal to 13, 14, and 15, and then you add them up. And that's what I did.
Professor, I'm going to take a picture, okay? So don't move it.
Yeah, go ahead.
Okay, you're good.
Okay. And then for C, between 7 and 10, that means 7, 8, 9, and 10. And if you did that, you add all of them up, you should get 0.000314 or something very close to that.
Professor,
Yes.
I got 3.106 times 10 to the negative 4.
Yeah, I think that was fine.
Okay.
Oh, if you leave your answer like that, yeah, that makes sense.
Yeah, you can leave it.
And I just left it as
times
0.0003.
You can leave it as times 10 to negative 4, or you can write it out 0.000314.
Okay, see, I didn't know that.
Yeah, either way,
That's good to know.
Either way is fine.
Okay.
So 3.106 is fine?
Yeah, times 10 to negative 4 though.
Yeah.
Yeah, that would be fine.
Okay, thank you.
Okay.
Mm-hmm.
And then the main is NP, the standard deviation square root of NPQ. And that should be straightforward. One is 1.5, the other is 1.16.
Yeah.
Right? And then number 5A, you are given that, and that's the number of living grandparents, right? And the question is, does this refer to a discrete or a continuous random variable? That would be obviously discrete, right? Number of grandparents, there's no half grandparents or a quarter grandparents, so that is discrete because it's going to assume integer values, right? B, they show that it satisfies a probability distribution. That means supposed to satisfy those two conditions. Each of the probability is a number between 0 and 1. And then when you add all of the probability, they add up to 1. Right? You add it yourself, they will add up to 1. And then C, what is the probability of at least one living grandparent? Right? So that means probability of X greater than or equal to 1. Which is the same as 1 minus probability of X less than 1. And 1 minus probability of X less than 1 is the same as 1 minus probability of X equal to 0, which equals 1 minus 0.71, which equals 0.29. Okay? And then D, what is the probability of 2 or 3 living grandparents? So probability of 2 or 3 will be probability of X equal to 2 plus probability of X equal to 3. Right? X equal to 2 and X equal to 3. So probability of X equal to 2 is 0.09. Probability of X equal to 3 is 0.03 from the information given. So you add the 2, will be 0.12. Right? And then the last two questions calculate the mean and the standard deviation. You use the formula for the mean, X times probability of X equal to X. Right? And then sigma square root of sum of x minus mu squared times probability of x equal to x. And that will be square root of 0.85 and it equals 0.921. Okay?
Yes, sir.
Okay, so one will be 0.5, then one will be 0.921. And most people got the right answer for that one though. Almost everybody did. Okay? Okay, I think we're done.
Okie dokie.
What is it?
Oh no, I said okie dokie.
Okay. Yeah, so we're done, and your exam is on Monday at the same time. And I will see you then. If you have any question before that, then let me know. I'll try and see if I can find a question on confidence interval for you to do and
I'm
send
literally
back to me.
saying goodbye right now, Goose.
Oh yes, for the extra credit. Yes, that'd be
Alright,
perfect.
so I'll come pick you up in like 30
Okay.
seconds. I'm getting in my car.
Yes. Are we
Bye.
free to go, Professor?
Okay, so nice having all of you in class, and I will see you on Monday.
Okay, thank you.
All right. Have a good rest of your day.